So if we have a sine graph, okay, if I want to sketch a sine graph, let's have a think about what the sine graph will look like. We are only draw the graph from 0 degrees to 330 degrees, okay, from 0 degrees to 330 equal to 360 degrees. Let's sketch the sine function first. Okay, so what's the sine function looks like? Y equals to sine theta. Y equals to sine theta. Okay, let's think about some values. Okay, let's think about some values. Okay, I don't know how many boxes I have, but let's start from 0. So if I have 0 degrees, okay, so we have theta here, and we have the sine theta value below. Okay, let's have a think. If I have 0 degree, what sine 0 equals to? Sine 0? How do we find the sine value, cosine value for the angles? Yeah.
Would it be 0 because sine is the y value and you get angle 0 just for your horizontal?
Yep, so you think about the unit circles. Okay, for the angle in the multiple of 90 degrees, you think about the angle line, it passes through here. That's the 0 degree. It make the intersection here. That intersection is 1, 0. The y value represents the sine value, so it's 0. So sine 0 will be 0 degrees. Okay, or sine 90 degrees. Okay, 90 will be here. The coordinates will be 0, 1. So sine 90 will be 1. Okay, sine 90 and sine 180. What's that? 0? Yep, 0. So that point is -1, 0. Sine 180 will be 0. And the last one is sine 360. What sine 270? 270, what 270 gives you? Okay, it's here. So it's 0, -1. So it will be -1. Okay, if you go for another 2 boxes. Okay, 360. What 360 gives you?
0?
Yep, 0, because it's same as 0 degrees. Okay, 360 degrees is the same as 0 degrees. So you have 0. Okay, that's a couple of values I know now. And I want to put those values on the axis and y-axis. So that's sine theta. That is theta. Let's say that's 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, and then I have each box is 0.1, so here is 1, and then 0.1, 3, 4, 5, 6, 7, 8, 9, 10. That's -1. Okay, 1 and -1. Okay, I will use red color to label the point. Okay, let's have a think. When theta equals to 0, sine 0 equals to 0. Okay, a point here. When sine is 90 degrees, I have 1. Okay, 90 degrees, I have 1. Which one is here? I have 180 degrees, I have 0. 270 degrees, I have -1. 360 degrees, I have 0. I have those points. Can you see all the red points? And let's try to find a couple of more points. Okay, in between. Couple of more points in between. Okay. Like, let's do a 30 degrees. What sine 30 gives you? Half?
Yes.
Yep, half. Okay, 30 degrees will give me half. So let's find 30 degrees. 30 degree is here. Okay, a third of 90, so I have half. Okay, another point somewhere here. Okay, in between 90 and 180 degrees, let's say 120. What's 120 gives us? Let's make, 120, maybe 150. Let's make an easier number. 150. What 150 will give us? Have a think how to calculate sine 150. What's the, reference is 30. Reference is 30, sine 30. And it's also the sine quotient, sine is positive. So sine 30 again is a half as well. So 150 will give you a half. Let's find where is 150. Okay. Okay, 120, 150, 150 is here, and have a half as well. Half is here. Okay. Okay, in between 180 and 270. Okay, 180 and 270. Let's make a 210. Okay, sine 210. What sine 210 gives you? Calculate that. Sine 210. Negative half. Okay, sine 210. 210 is here. The reference angle is 30. But it's the tangent quadrant is negative sine 30, so it's negative half. So 210 will be negative half. So 210 is here, third of the place, and you have negative a half, which is the point here. Okay, the last one, let's make a 330. What 330 gives you? Yep, negative a half. Negative 330 is here. Reference is 30 degrees as well. That's the cosine quadrant is negative sine, so it's negative a half as well. So 330 is somewhere here. Okay, that's 330 and negative a half, which is here. Okay, I think I have plot enough point. Like I keep adding points on. You can see the trend of this graph if you can connect them. It's a graph like that. It's quite light. Okay, I'll just connect the trend of the graph. It's a graph like that. It's not a straight line. It's not like half circle. It's more like a smooth curve to connect all of these points. Okay, let's have a look at this curve. What is the maximum value for this curve, for this function? 1. What's the minimum? Negative 1. Okay, sine something is a ratio, is like more like opposite over hypotenuse. offset over hypotenuse can never be greater than 1. Okay, can never be greater than 1 because your offset is less than the hypotenuse. So the fraction will be less than 1. And you have some negative values of those ratios. Then you will have -1 is the maximum. You won't go beyond that -1. So that's why your graph looks like that. You have a maximum turning point over there. Is this coordinate is 90 degrees, 1. And you have this point is to 70 degrees, -1. That's the minimum and maximum point. And on the x-axis, you have 360, 0. You have 180, 0, and you have 0, 0. Okay, that's the graph for this angle turn one circle. Okay, one cycle. It's just turn from the 0 to 360 is one full circle. So have a think, if I keep turning another one, what's the graph will look like? If my graph like can have like 360, have then I will have 540. Like what's the point? If I keep going for 720 degrees. Okay, let's have a look. If I have, that's my graph from 0 to 360 degrees. How about if I have another one here? Okay, if I have like 90, 180 to 70, 360, and that's 720. Okay, if I have that, what's the graph will look like? Yeah, it will repeat because like after you keep turning, after you go back to 360, then the angle you turn will be exactly the same as the first circle what you're trying to do. So they will repeat the value. Okay, they will repeat the value. So you will have roughly like this. Okay. Before you have 0, 0, 90 degrees you have 1, 180 you have 0, and then 270 you have -1, 360 you're back to 0. And then the next 90 degrees you will go up to 1 again, and back to 0, and then go to -1, and then back to 0. So if you keep having this graph, it's just a graph like that. You just keep going for another time. Okay, just repeat it, repeat it. So the basic graph is from 0 to 360 degrees. Okay, 360 degrees, which is here and here. Okay, so this part of the graph is the basic graph, and then the next 360 degrees will repeat once for this graph. The next 360 degrees will repeat again. So you have like this graph never ends. Okay, just infinite many like values. You just keep going like this shape. And also you can go left hand side. You can go for the left hand side. So I can have something like that. You can keep going. You can just keep going that way. Okay, so that's my sine graph. Okay, that's my sine graph. Okay, it can keep going, but we only think about the graph from 0 to 360 degrees. And let's go back to our notes. Okay, that's the graph for sine. And from 0 to 360 degrees, the maximum value is 1, the minimum value is -1. So some special points you need to remember is this point, this point, this point, this point, and this point. Okay, those points are the special ones. When you sketch the graph, you need to label those 5 points. Okay, you need to label those 5 points. Okay, Then let's think about the cosine graph. Let's think about the cosine graph. Let's still think from 0 to 360 degrees, 0, 90, 180, 270, and 360. That's 1, that's -1. Okay, what's cosine 0 equals to? Cosine 0? 1, yep. Cosine 0 is 1, so I have the coordinates here. Okay, what's cosine 90? 0, yep. Correct. Cosine 180, -1, yep. Okay, that's a good practice. Try to sync together. And 270. Cosine 270, 0. Okay, so it's below here, 0, -1. So x is 0. 360. It will be the same as 0 degrees. Okay, 360 will be the same as 0 degrees. That will be 1. Okay, you can see the points over there. If you connect that, okay, graph will be like that. Well, it's not, looks quite good. Okay, that's a better graph. Or something like that. So you will have coordinates 0, 1, 90 degrees, 0, 180 degrees, -1, 270 degrees, 0, and 360 degrees, 1. But it should be symmetrical, but like my sketching is not very good, so this not looks quite good. Okay, something like that. So compared to the cosine, like if you want to keep going for another 360 degrees, you just repeat the graph again. So your base graph from 0 to 360 degrees will look like that. Well, let's compare. Come back to compare those two graphs. Anything in common you can talk about, or anything different? Yeah. Do you mean sine 30 and cosine 30 will be the same?
Yeah.
Not really. Have a think about cosine 30 equals to what? And yeah, cosine 60 will be the same. Cosine 60 and sine 30 will be the same. But let's have a think about this, the general shape of this graph. Can sine graph become cosine graph by some movement, by some transformations? How you can shift this graph to make sine look same as cosine? How these two graphs can be similar to each other? If you hide this graph from 0 to 90, maybe you should. If you can hide this part and start to think about this trend of this graph and compare this one, are they look the same? If you shift this graph 90 to the left, have a think about that. If you shift that graph 90 to the left, yeah, you can think like that way. Okay, so if you move the sine graph 90 degrees to the left together, then it will be the same as the cosine graph. Okay, it will be the same as the cosine graph. So if you shift that, let's just shift it. Okay, that will shift to here. This point will shift to here. This point will shift to here. And this point will shift to here. Okay, all shift to the left. Okay, and compare the graph. That looks pretty much the same as the cosine. If you keep going, don't forget, like, your graph can keep going. Okay, so not stop at this point. So you will have here as well. So it's exactly the same as the cosine graph. So the difference between the sine graph and the cosine graph is just a movement for 90 degrees to the left or to the right. Okay, sine want to become cosine, move left to 90 degrees. If cosine want to become sine, just move right by 90 degrees. Okay, that's the shape of the graph. Still, you need to remember that point, that point, that point, that point, and that point. Okay, that's the really, really basic single sine and cosine graph. So what is the amplitude? Amplitude is the maximum displacement of the graph from a reference level. Well, what's the reference level? The reference level is 0. Okay, the middle of your graph. Okay, where's the middle of your graph? The middle of your graph is 0. And then from the middle of the graph, go to the maximum of the graph. What's the displacement? From the 0 to the maximum? 1. So the amplitude is just 1 for both graphs. Okay? Because your sine or cosine graph, the maximum is 1. The minimum is -1. The middle value will be 0. That's the reference level. Okay? Middle is the reference level. In the middle of the graph. Then from the middle of the graph, going up need to go 1 unit. Go to the minimum point needs to go 1 below to reach the minimum point, which means your amplitude is 1. Okay, the maximum movement will be 1. Okay, not 2 is 1. Okay, it's from the mean level, the middle level. So reference level is the middle of the graph. Where's the middle? 0. Y equals to 0 is the middle of the graph. Okay, the period of a graph. The period, okay, the first thing we talk about is amplitude. The second thing we will talk about is the period. Okay, so the period of the graph is the time taken to make one complete cycle. Okay, the period is you have a complete cycle, then everything will repeat after that cycle. So what's the period do you think you have for sine or cosine graph? Yeah, 360 degrees. Okay, 360 degrees will give you a full cycle. From 0 to 360, the duration from 0 to 360 is 360. So 360 degrees is the period for both sine and cosine graph. Okay, for both sine and cosine graph, 0 to 360 degrees. Okay, state the second angle between 0 to 360 degrees that gives same value for sine theta. Give you a hint, first angle is 153 degrees. So basically I want to know sine 153 degrees equals to sine what? Okay, sine 153 degrees equals to sine what? Let's go to see the sine graph. Okay, let's have a look at the sine graph. Okay. 1, 2, 3, 4. In between 90 to 180 is cut into 4 equal lengths. Then here will be 135. Half of it, 135. And that's 22, 157.5 is here. So you have the angle is 153 degrees. Okay, 153. So it's somewhere about here. Okay, let's say that's 153 degrees, and you have make a y value. The y value is here. Okay. Oh no, it's not very exact. It's not necessary to be half, but like around that value. But there will be another angle give you the same y value. Where is that angle? Yes, it's over there, right? That angle. It's this angle here. Okay, without thinking about the reference angle, let's just see from the graph how I can work out this value. Okay, if you don't know the knowledge about reference angle, I'll tell you this graph is symmetrical. Okay, from 0 to 180 is symmetrical about 90 degrees. From 180 to 360 is symmetrical about 270 degrees. If you know this property, how you can find out the question mark is symmetrical? Yep, so the distance from here to here will be the same as the distance from here to here. Because it's symmetrical, you have vertical lines, horizontal lines, then you will have the middle, which is 90 degrees. So if it's the middle is 90, so I can use the formula question mark plus 153 divided by 2 will give you 90 degrees. Okay, add them, divide by 2 will give you the middle. Okay, the formula like x1 plus x2 divided by 2 will be the middle, y1 plus y2 divided by 2 will be the middle. So you will have that. So question mark plus 135 equals to 180. So the question mark equals to 27 degrees. So this value here is 27 degrees. Okay, this angle here will be 27 degrees. So you will have 27 here. So the theta will be 153 and 27 degrees. They give you the same value. Okay, cosine will be the same. Okay, cosine will be the same. The whole graph is symmetrical about x equals to 180. Okay, the whole graph is symmetrical about 180. Okay. Let's have a look at example 2. Well, let's have a think about this. What cosine 153 degrees equals to? Equals to cosine what? Okay. Cosine 153 equals to cosine what? It can't be 27. Because 153 is in the second quadrant, is negative. 27 is in the first quadrant, is positive. It can't be the same. Okay, so let's have a think. 157 and which value will give you the same cosine value? Okay, where's 157 again? 157 will be somewhere around here. 153. 153. Okay, you have made a y value here. Okay, for that y value, okay, draw a horizontal line. There's another point give you the same, which is the point here. Okay, which is the point here. This question mark place. Those two x will give you the same cosine value. Is symmetrical about 180 degrees. Symmetrical about 180 degrees. Therefore, 153 plus question mark divided by 2 will give you 180 degrees. Okay, 153 plus question mark will give you 360 degrees. So question mark should be 702. Okay, 207 degrees. Okay, 207 degrees. And this big angle is 207 degrees. So cosine 153 and cosine 207 degrees will be the same. So you will have 207 degrees here. Okay, 207 degrees here. So you can use the sine graph and the cosine graph, find the same values. Okay, you can use same graph, those two graphs to find the values. Okay, the last one is we want to sketch y equals to cosine 1 on 3x. Okay, 1 on 3x. What do you think this thing will influence on your graph? What's the influence on your graph? How your graph might change? Just any guess? Because we'll prove that in a minute. Well, you time something in front of x. That's what cause a dilation. Right? You stretch your graph. Your graph will be stretched in some way. Okay, or compressed in some way. You're just not really sure about that. Okay, it will get stretched or get compressed. Like that's our guess. And if we can sketch it, okay, let's write down this. We have y equals to cosine 1 over 3x. Okay. Create a table first. Okay, so what I want to do is okay, so remember the special values we used before? Okay, the special values we are using is 0, let's say that's x. That's a third x. That's cosine a third x. Okay, before the special angles will be 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Now I will have a third of that is 0, 30 degrees, what's that, 60 degrees, 90 degrees, and 120 degrees. Okay, what's cosine 0? 1. Okay, cosine 30? Cosine 30? Yeah, square root 3 over 2. Cosine 60? A half. Okay, cosine 90, 0, and cosine 120, cosine 120. What's the reference? 60. So, but it's in the sine quadrant. So it's negative cos 60. That's negative a half. Okay, so cosine 120 will be negative cosine 60 degrees, will be negative a half. Well, you can see from the 0 to 360 degrees, I'm not really complete one cycle of the graph. Okay, if I can sketch this. If I can sketch this. let's say that's 90, 180, 270, 360. Okay, I'll draw quite small scales. 1, 2, 3, 4. That's 720. 2, 3, 4. That will gives me 360, 1080. Okay. So what I can see is when x equals to 0 degrees, I will have 1. Okay, when it's 0 degrees, I will have 1. Okay, when is 90 degrees, I have root 3 over 2. Okay, root 3 over 2. Let's have a think. What's root 3 over 2? Root 3. This calculator. Root 3. Divide by 2. Okay, 0.866. Just say approximately somewhere here. And 180, it gives a half. Somewhere here. 270 gives me 0, which is here. 360 is negative a half, which is here. Okay, let's say if I keep going, I'm not really go for that value. You can see that's not a complete cycle. If I connect the graph, there will be some shape like that. It's not like the normal shape we'll have. So if I keep giving x values, let's go for let's say what's 540 gives us. Okay, if I have 540, that divide by 3, I will have 180. Okay, a third x, it gives you 180. So what's cosine 180? Cosine 180? What's the intersection? Negative 1, 0. Okay, x value is negative 1. So cosine 180 is negative 1. So at the point 550, here is 540, you will have negative 1. Okay, you will have negative 1. So you will have the coordinates here. Okay, that's negative 1. So if your graphs keep going, you will have this point here. Let's say what I have 810. If x is 810, divide by 3, you have 270. Okay, we have 270. What's cosine 270 gives you? 0. Okay, 270 gives you 0. So at the point 810, you have 0. Okay, that's 810. That will give you 0. Okay, the point is here. So your graph will come back to here. And the last point, let's say the end point, 1080. If you have a third of that, is 360. Okay, what's cosine 360? 1. Okay, same as 0, cosine 0. So it's 1. So 1080 will give you 1, which is a point here. Okay, that's the shape of the graph. Okay, that's the shape of the graph. So the point I'll label is 0, 1, 270, 0, 540, comma, -1, 810, comma 0, and the last one is 1080, comma 1. That is y equals to cosine a third x. Okay, compared to cosine x and cosine a third x, what has been changed? Yep. Yeah, have a full cycle. So that's correct. So we can say the period has been made longer. Okay, my period has been 3 times as before. My period for the original cosine x is 0 to 360 degrees. Now the period for this graph is 1080, which is 3 times as before. Okay, if you have a third there, my period will be stretched by 3 times. Okay, my period will be 3 times larger. Then have a predict. If I have cosine a quarter x, what's the period will be? Yeah, it's 4 times as 360. Okay, it's 4 times as 360. How about cosine 2x then? So what that will be? Yep, so you will have, so that you can write cosine 1 over a half x. You can say that's 1 over a half x. So that can be period will be 360 times a half. That's 180. So this period will be shorter. This period will be shorter. Your graph is actually compressed. But for this one, your graph has been stretched. Okay, stretched by 3 times. But if it's 2x, then it will be compressed by 2 times. Okay, compressed in. Okay, so that's how those numbers will get influence on the shape of the graph. Okay, it influence on your period. Okay, it influence on your period. And you can see all these special points has been times by 3. Okay, before you have the special points is 0, 90, 180, and 270 and 360. Now you have 0, 270, 540, 810, and 1080. Okay, it all has been stretched in x by 3 times. Okay, so x has been enlarged by 3 times compared to the original one. So next time when you sketch a graph like that, you don't really need to plot all the points. You know what the effect will be. Okay, compared to the original base graph and the new graph. Okay, so that's all for this chapter.